A lambda expression is a simple code block that accepts variable and produces an output. Through this course, we are going to understand what is lambda expression and why is it used in Java. Implementation of various aspects of lambda expression will also be discussed using IntelliJ IDE. Concepts like method reference, constructor reference, exception handling, functional interface, etc. will be discussed with respect to lambda expression in Java. So put on your thinking hats and let's get started with this session on lambda expression in Java.
If you haven't subscribed to our channel yet, I want to request you to hit the subscribe button and turn on the notifications bell so that you don't miss out any new updates or video releases from Great Learning. If you enjoy this video, show us some love and like this video. As it said, knowledge increases by sharing. So make sure you share this video with your friends and colleagues. Make sure to comment on the video if you have any queries or suggestions, and I will definitely respond to your comments. Hello everybody. Welcome to the session where I'll be talking about Lambda expressions in Java. So before getting started, let me tell you what is the agenda for the session, what all topics I'm going to discuss in this video. So I'll be talking about first what is Lambda expressions, confined to Java programming language. And then why are we making use of this Lambda expression, as this Lambda expression is a new addition to Java programming. So why was it added? What was the requirement behind it? Then going ahead, I will talk about the syntax that is followed for writing Lambda expressions in Java. And then the one important concept, that is your functional interface, which is linked to the concept of Lambda expressions, that will be discussed. And then the implementation codes also for the examples of functional interface, for the examples of how to make use of Lambda expressions in Java will be discussed. I'll be using an IDE to type the code for all these examples. And then moving ahead, we will take a further example of how we can use Lambda expressions in creation of a thread. As Java is a multi-threading language, so implementing or using the concept of Lambda expressions in threads is also important, that we will see here with the help of an example code. And then lastly, we will talk about the method reference and constructor reference in Lambda expressions. At the end of the session, I will talk about how you can perform exception handling in Lambda expression. So let's get started. Now let me talk about Lambda expressions in Java. So what is Lambda expression? As the name itself makes it little clear, that is, it is an expression, meaning a line of a code or a block of a code. But the block of code or those expressions, those lines of code in Java will not have any name assigned to it. Okay, so Lambda expression is a block of code without any name assigned to it. Lambda expression implementation code can be provided wherever it is made use of. Meaning, suppose if you have to make use of a program that is reversing the characters of a string. So normally what we do, we write a method in Java where we write the codes for reversing the characters of a string, and then wherever it is required to be implemented, we call that particular method. This is how we work in Java programming, right? But if I have to use Lambda expression, what I will do is I will not be defining any separate method or anything, any separate piece of code, but wherever the reversing the characters of string is required, there itself we will write the Lambda expression, which will contain the codes for reversing the characters of a string. Okay, so this is what I meant by when I said Lambda expression implementation code can be provided where it is called. Okay, now it represents an anonymous class. Anonymous class meaning a class without any name assigned to it. Right? So anonymous class concept is there in Java. So Lambda expression also is not given any name, right? So it represents, or it is similar to the anonymous class in a way that even anonymous class doesn't have any name assigned to it, and it is declared or defined there itself where it is required. Similarly, Lambda expression also doesn't have any name assigned to it, and it is defined there itself where it is required. Okay. Second, it can be referred as a method without a name, right? So we include certain piece of code, certain implementation code inside a method in Java programming. And same piece of code, if you don't want inside a method, you can directly write it down under a Lambda expression and at the place itself where it is required to be called. Okay, so this is all about your Lambda expressions in Java. Now let me talk about use of Lambda expressions in Java. That is, why was this requirement of adding Lambda expression concept in Java? As this Lambda expression concept is added as a new features in Java programming under Java version 8, but why was the requirement of it? So to understand that, we have to understand first why we create a method in Java. Suppose any given piece of code has to be repeatedly called again and again. We write that piece of code inside a method. And then wherever required, we call that method again and again, right? Similarly, Lambda expressions are made use there where any given piece of code has to be used exactly once. Suppose I take an example of reversal of a string. Okay? Reversal of a characters of string. Okay? So in that case, what I'll have is that I'll have a piece of code where it is going to reverse the characters, right? Now, this can be included inside a method. Suppose it is included inside a method M1. But this method in the entire piece of code, in the entire program or a software, I have to use only once. Then including it inside a method and calling that method somewhere in my program, in the actual code, doesn't make much sense. In fact, it increases the overhead. So to solve this problem, what was done is the concept of Lambda expression was introduced. That is, you can put this method inside a Lambda expression, meaning you don't have to create a separate method here. Suppose I am using M1 method in the code at this point of time. Here itself I can write a Lambda expression that will contain the same code which is here for reversal of the characters of a string. And this Lambda expression will not have any name like this method had M1. Because these expressions of reversal of characters of string has not to be called again and again that it needs a name. It has to be called only once. So if it has to be used only once, even if there is no name, directly the code is written there, then also it makes no difference. Right? So doing this process solves the complete overhead of creating a separate method, calling that method, and method execution takes a long process at the backend in memory. But if the code is written there itself in the form of Lambda expression, all this backend overhead is reduced. So the advantage to this is first is your less coding is involved. You don't have to explicitly write a method, call the method and all that. So coding is reduced. Secondly, codes are benefited here which has to be called or used in the entire program only once. Okay. Lastly, it encourages the concept of functional programming. Lambda expression is the concept from the functional programming languages itself. It has been added to the object-oriented programming languages also, but as it belongs to originally from a functional programming language concept, it encourages functional programming also. Okay, so this was all about why was the Lambda expression used or was introduced in Java programming. Now let me tell you how to write Lambda expressions in Java. So to write Lambda expressions in Java, there is a proper syntax that has to be followed like any other programming concept. So the syntax here is in various formats depending upon the number of parameters being passed to that block of code or to the Lambda expression. Okay, but basically if I try to explain the syntax of Lambda expressions in Java, it consists of three parts. Okay, the first part is your parameters. Okay, so this is your parameters. Second is a arrow symbol, okay, pointing towards right side. And then this is the second part, okay, a arrow. And third part is the Lambda expression codes. the actual Lambda expression code. Okay, so the first part, that is parameters, are included inside a round bracket. Then followed by which there will be an arrow, and the last part is included inside a curly bracket ending it with semicolon. Okay, so broadly this is the syntax being followed. But now depending on the parameters, this part of the syntax differs. How? If there is no parameter being passed to this Lambda expression code. To understand what parameter is and what this expression codes is, consider a method. Okay, suppose there is a method void m1, and this method is having a parameter maybe string a1. Okay, and what the code consists of is the code to reverse the characters of a1 string, right? Now, if this method I don't want to write because this method is being used suppose only once in my program, I have to convert this into Lambda expression. So the syntax, how is that related to this method? Which part of the syntax covers which part of this particular code? Let me tell you, that will make it clear. So parameters here are these parameters which are passed to this method. So in this method code, only one parameter is being passed, that is a1, which is of type string, right? So just write a1 here in the round bracket. Okay, then arrow symbol, and in the curly bracket you have to write this part represents this curly bracket. Okay, the first part represented the parameter to the method. Fine. So the code to reverse the characters of string char a1 will be over here. So as this parameter a1 or the variable a1 is being used in this Lambda expression, those are written here in the round brackets. Okay, so this is how it is defined. Now suppose there can be sometimes a code which does not require any parameter. Okay, there may be suppose a code called as void. Suppose this method is there, void m2, which is not taking any parameter, and it prints the message. Simple, there is system.out.println message inside this, so it prints some message. It will not take any parameter, right? So this method has to be converted in the form of Lambda expression. Then how will you write? So in that case, parameter will not be there, so it will just be a empty round bracket. Okay, followed by which there will be an arrow symbol, and then there will be this curly brackets which will contain the system.out.println code to display the message. Println. Right? So this is how we write Lambda expressions in Java. Number of parameters keeps increasing. You can add all those parameters here, separating it with a comma. You can see the second syntax written here. First parameter, second parameter, third parameter, and number of parameters can be there. All you can write in the round bracket, separating it with a comma. So I hope you are clear with how to write Lambda expressions in Java. Now let me talk about functional interface. So what is functional interface? An interface having a single abstract method inside it is called as your functional interface. Now what is an abstract method? A method which is not having a implementation code then and there is called as your abstract method. Meaning the interface will only have the method declaration. The implementation will not be there. Normally in Java programming, an interface has abstract methods defined inside it. But if an interface has only single public and abstract method, then it is called as your functional interface. These methods can have n number of static methods and n number of default methods. Still, it will be called a functional interface. Suppose, for example, I define an interface here. Okay, interface I1. Inside this, I define a public method, public abstract M1 is a method. Then I define one more method inside this interface I1, that is your public abstract M2. Now, is this interface a functional interface? No, because this interface has two abstract methods defined inside it. But if suppose this first method is public abstract M1, second method is public but not abstract. Let me erase it for you. So, public static. If it is a static method, and this is your abstract method. So abstract method will not have this implementation code here, but static method will have the implementation over here. Okay. Then is it this interface I1 a functional interface? Yes, it is a functional interface because there's only one public and abstract methods. It can have one more. Suppose it has public, not public, it has default M3 and then its implementation code here. Then in that case, this interface I1 is still a functional interface. So interface can have n number of static methods and number of default methods, but there should be only one public abstract method. Then it is called as your functional interface. There are certain examples already existing in the packages of Java. So runnable, predicate, these are the examples of functional interface. Runnable interface has only one method defined inside it, one abstract method inside it, that is your run method. So it is a functional interface. Runnable is a functional interface. Similarly, predicate also has only one method, that is called as your test, defined inside predicate interface. Hence, predicate is also a functional interface. So this is all about the functional interface. Now let me talk about functional interface implementation. So to implement the functional interface, I'll be using IntelliJ IDE, where I'll be writing a code how to write a functional interface and then how to implement the methods of the functional interface into another class. So let's go to the IDE and write the code. So here I have already created a file with the name of example. So class is example here, and then public static void main method is also defined inside it. Now, as I have to write a functional interface codes, so I have to create an interface here, right? So creating a functional interface has the same syntax as creating any other interface in Java. So interface, keyword, and then the name of the interface. You can give any name here. I'm giving the name as string example because I'm going to write a code for reversing the characters of a string. Okay, so the interface, now we should have only one abstract method inside it, right? So I'll define a method which is having a return type of string. Okay, and the method name is suppose reverse, and it takes the parameter also of type string x. Okay, as the method is abstract, we need not use abstract keyword here, but not defining any implementation code, not providing its implementation, ending it with semicolon itself says that it's an abstract method. Now, inside this, we can have n number of static methods. Still, this will be a functional interface. If I define another method, suppose void m1, so this is no more a functional interface. Okay, because we have two methods here which are abstract. But I can have a static method here, static void m1, and then it will have an implementation code here itself, right? Similarly, you can have default n number of default methods also, void m2. Okay, still this will be a functional interface. So the definition of interface is clear, I guess. How we know that if the interface has only one abstract method, still it is a functional interface. Why is this methods not counted? So to understand that, let's see a class here. So class may be string implement impl. Okay, right? So if this class implements string example, then it will ask to override, right? In the IDE, this is a defined feature. It will ask to implement method. So you can see here, it is asking me to just implement reverse, which is abstract method, and the second one is void m2, which is a default method. Static method is not being asked to be overridden. Okay, so default method, if you don't override also, it is fine. Only this reverse method has to be definitely. See, I'll only override the reverse method. Still, it is fine. There's no error, compile time error here. Okay, so that's the reason whenever in later stage I want to use a method without a name of this interface, then only this reverse method will be actually called as a method of the interface. String example. Okay, so that's the reason you can see here clearly that which method has not been counted and which is being counted. So that's why even if one abstract method is there in the interface, then it is a functional interface. So let me just quickly delete all these. Okay, so as this class we have already created and it is overridden. So as like any other interface, functional interface, we have to implement or override the method reverse into the class which this interface is being implemented by. And there in that class, you have to provide the functionalities of implementation code for this abstract method reverse from the interface. Okay, so here we'll provide the code. So let's write. So I'm going to write a code to reverse the characters of the string. So here I'm going to take one empty string maybe C1 equals to, okay. Now to reverse it, you have to use for loop here. Int I equals to, starting from beginning, right? So x dot length -1, because length will give the total value as starts from, the index value starts from 0, right? So it should be -1. I minus minus will start from last, will go till the first. Okay, before that, I should be greater than equal to 0 and I minus minus. So now in this we can write C1 is equal to C1 plus x dot caret, okay, I. And then we can return this C1. So return statement can be written here. Return C1. Okay. So this for loop is closed here. This reverse method is closed here. And this class is closed here. So why is this error here? Okay, is it not returning? Okay, this return will be outside this for loop. This should be over here. Not okay. Let's not get confused and let it be over here. Okay. So fine. Once this for loop will complete, then it should return the string C1, right? So okay, this is correct. Here it should be C1. So this is how we'll implement this interface. Now to call this, I'll go to the main method and the name of the class is string impl. So I'm going to create an object for this class. Okay, e equals to new string impl, and using this we can call reverse. Okay, let's pass the string from here as it takes a string parameter. So hello. Let's see, it should reverse the characters of hello and display it to me. So let's check the output. Okay, I'm not printing it, guys. So let me just quickly write system.out.println, and at the last we'll have this. So okay. So you can see it is printing the reverse characters of hello. So basic point here was to understand functional interface. So this is called as your functional interface, even though it has another methods which are static and default. So you can have n number of default and static methods, but there should be only one abstract method. Then only this will be called as your functional interface. So this was all about the implementation of functional interface. Now let us talk about functional interface with Lambda expressions. So functional interface with Lambda expression, how can it be written? So Lambda expressions are used to implement that one abstract method which is defined inside the functional interface. That's why we have this concept of functional interface. As in the functional interface, there is only one abstract method, and Lambda expression refers to the method without any name, right? So it will be automatically understood that Lambda expression, if it is referring to the particular interface which is having only one abstract method, then it means that Lambda expression is referring to that one method which is there inside the functional interface. That's why, along with Lambda expression, the only concept of functional interface can be used. We cannot use that interface which has multiple number of abstract methods. Okay. Few things to be kept in mind here, that return type of the Lambda function, that is the Lambda expression code, should be same as the interface type. Lambda function here refers to the Lambda expression or the Lambda code. The return type has to be of the same type of the functional interface. Meaning, after the Lambda expression is executed, the value returned from it should be stored in an object reference of type functional interface. For example, if you see here, there is public static void main method inside the class example. Here, the predicate functional interface is used. Predicate is an inbuilt functional interface in Java programming, which has only one method called as test. This test method of predicate interface is built for comparing the given data, the given parameter, to others. Test will have only single parameter. So that's what here you can see when the test is called, the test function is called, it is having only one parameter. This is the Lambda expression written. X arrow. So X is a parameter to this Lambda expression, having arrow symbol after that, and then in the curly bracket ending with semicolon is the body of the Lambda expression. So inside the body of the Lambda expression, there is a code written to check if this X value is same as the text hello or string hello, then it should return true, else return false. Okay, so you can see the return. This is the Lambda expression starting from X till last. So the return type or return value after the Lambda expression is executed is stored in a reference, in an object reference P1, which is of type predicate. Okay, predicate of type string. So P1 type, data type is string, but it is of reference type predicate. Okay, so predicate is a functional interface. Now you can see here, without being the name used in implementation, the test method name used, directly this test method is being called here by the object reference of type predicate. P1 is object reference, so P1.test is being called with one parameter passed here. So this definitely will call this Lambda expression, will invoke this Lambda expression, because there is only one method inside predicate interface, that is your test method, and this Lambda expression is referring to that itself. Okay, that was the reason that the functional interface should have only one abstract method. So this was an example of inbuilt predicate interface, which is a functional interface having one abstract method test, and how in Lambda expression this is called. Before understanding how to write the complete Lambda expression in Java, let us know few tips and tricks, or you can say few rules to be remembered for Lambda expressions in Java. So rules for Lambda expression in Java is that the variable type should be of interface type. That is, when the Lambda expression returns or executes completely, and finally it should be referred by an object reference of type interface. And that interface should have only one method, and that method should be abstract public method. Next rule says that the Lambda expression should have same number of parameters and same return type as that of the method in that interface. Meaning, if I am referring to a functional interface which has one abstract method which has only one parameter passed to it, then while defining the Lambda expression for that, we should have only one parameter for the Lambda expression also. If the method defined inside the functional interface has two parameters, then the Lambda expression being written for that particular interface should have two parameters given to it. So that says your second rule. So these are the two rules which you have to remember before writing Lambda expressions in Java. Now let me talk about the Lambda expression program in Java. That is, I'll be going to the IntelliJ IDE where I'll be writing the code and demonstrating you an example of Lambda expression code. So let's go to the IDE. So here I have already created a file with the name of example. So the class name is also example. Public static void main method is also defined there. Now I have to write a Lambda expression here. So to write a Lambda expression, I should have a functional interface. Either I can use any inbuilt functional interface in Java programming like runnable, predicate, or I can create my own functional interface here in this code itself. So I will demonstrate you by creating a functional interface in this code itself. So let me write interface. Okay, so the interface name suppose is your string example. Now inside this interface, I'll have a method string reverse. So I'm going to write a Lambda expression for reversing the characters of a string with the help of functional interface. So this will take a string parameter again, okay, of type string. The parameter will be of type string. So this is your interface with one abstract method. So it is called as your functional interface. Now to implement that, we don't have to use implements keyword or anything because I'm going to use the concept of Lambda expression here. So just you have to write class example, that's it. And in the main method itself, we can write our rest of the Lambda expression code. Okay, we need not implement the interface string example to use the method reverse. Okay, so how can it be done without implementing it? Let's see with the help of Lambda expression. So what I'll do here is that as before writing a Lambda expression, the Lambda expression result should be referred by object reference having of type interface, right? So the interface name here is string example. So string example, suppose result is equal to the parameter passed. Now here I will write the Lambda expression. So the syntax for writing Lambda expression is first in the round bracket I should write the parameters of the Lambda expression. So let's write that. Here the parameter will be same as the parameter to the method of the interface. So method of the interface is reverse method. Reverse method has only one parameter, that is string x. So this Lambda expression, if it is referring to this particular method, then it should be having only one parameter. So yes, it is referring to this method because the return type is of string example, that is same as this interface type. So definitely this Lambda expression is referring to the method reverse. So it should have only one parameter passed to it because there is only one parameter to method reverse. So let it be x, or we can give any other name just not to be confused. Okay, then the statement, the syntax of Lambda expression says arrow symbol followed by which there should be curly bracket which should end with semicolon. Right? Now inside this I will write the code for reversing the characters of a string. So the code will be simple ones. So let's take a empty string. Okay. After that, for all the characters of the string, int I equals to s1 dot length minus 1. I should be greater than equal to 0. I plus plus. I plus plus. Sorry, not plus, as we are starting from end. So it should be I minus minus. Now for all of these, okay, let's not have this, as there's going to be only one statement. So C1 is equal to C1 plus S1 dot caret. Okay, I. Now this should return C1, right? So this is how we write a Lambda expression. It should end with this round curly bracket and then semicolon. So this is your Lambda expression code. Okay, so in place of overwriting this method reverse from and implementing this interface string example, as it is a functional interface, we can just simply make use of it directly here by using Lambda expression. Okay, now how to demonstrate or print the result of it. So to print the result of it, let me have dot string system dot out dot println, and here you have to call the method That is your reverse, right? And with the help of which object you can call? The object reference used here. So result is the object reference being used to store the output of this lambda expression. So result dot reverse. Okay, and you can pass the string here. That's it. Now let's execute and check if it's working fine. So you can see here, yes, it executes fine and returns the reverse of the each character of the given string, hello. Okay. So this is all about your implementation of lambda expressions in Java. So you can see here you have to make use of this. Now if suppose here I define one more method, void m1 and like this, then there will be the error. Okay, the complete code will have an error, and when you try to run this, you can see what message it throws. So it says Java example is not a functional interface. String example is not a functional interface. So clearly you can see here that it says that it is not a functional interface. It means it should have only one method. So you have to have only one abstract method inside it. Then it will not throw any error and show the result correctly. So I hope you understood the whole concept of functional interface, how it is linked with the lambda expression. Now let me talk about lambda versus interface. That is, what is the difference between lambda normally and interface? As lambda is being interlinked or related to interface, so it's important here to understand what is the difference between these two, or is there any difference? So yes, difference is that lambda expression can be used only for those interfaces which has single abstract method inside it. And such interfaces are called as functional interface. So lambda expression can be used only for functional interface. Few examples of functional interface are runnable, predicate. So all these inbuilt interfaces in Java have single abstract methods. The interface can have n number of static methods, but lambda expressions is applicable only for those interfaces which are having single public and abstract method. That is your functional interfaces. It cannot be used for more than one abstract methods. That is, the interface has more than one abstract methods, then lambda expression cannot be used for such interface. Now let me talk about how can you create a thread using lambda expression. So to understand that, we have to go to the IDE. So I'm going to use IntelliJ IDE, where I'll be writing the code of how to create thread using lambda expression. So let's go there. Here I've already created a file with the name example. So the class name is also example, having public static void main method inside it. Now let us write a code here for creating a thread. Okay, so we know that we can create thread using two ways. One is your runnable interface and one is your thread class. So here I'm going to create thread using thread class, but I'll be using the concept of lambda expression here. Okay, so how can we make use of it? Let's see that. So in this, I'll be creating a thread. Okay, so thread class T is the name of the thread, use equals to new, then thread constructor. So inside the constructor of the thread, I am going to write the lambda expression, which will be invoked once this thread constructor is invoked. Okay, so to write a lambda expression, the syntax we know already, right? That is your round bracket. So as there is no parameter which I'm going to pass to this lambda expression, so I'll just have an empty round bracket and then arrow symbol, and then we need to have the curly brackets, the body of the lambda expression. Okay, so in the body of the lambda expression, what I'm going to write is for, let's just print the double of the numbers from 1 to 5. Okay, so I less than equal to 5, I plus plus. So here I'm going to write that, okay, let me not have so many curly brackets, as I'm going to write only just one line of code here. So even it will work without the curly brackets. So it is going to print something thread plus thread plus t, okay, I into 2. So I'm just going to simply display. Now this should end with semicolon. Okay, so this is your code. Okay, now after this, we should start the thread also. So t.start, then only this constructor will be invoked and the code will run. So you can see here, this is how we refer to or write a Lambda expressions from a thread. Okay, so I've created a thread here using this Lambda expression, meaning this Lambda expression is passed as a parameter to the constructor of the thread, and it will complete its execution from there itself. So we can just check the output of this. So you can see the output of this, that this is what I'm trying to print. From 1 to 5, I'm printing the double of it multiplied by 2. So 2, 4, 6, 8, and 10. So output is correct. So this is as simple as writing a simple thread, just that we have to write a Lambda expression over here. So you need not have a separate method somewhere and then invoke that method with the help of this thread, but directly that method code, you can write it here in the form of Lambda expression. So this will definitely improve the overall performance of the code. So I hope you understood this, how to create a thread using Lambda expressions in Java. Now let me talk about Lambda value capture. So what exactly is there under Lambda value capture is that I'll talk about two things here. One is the output of the result of the Lambda expression is referred by an object that is of type interface. And second point is that the variables which are declared in the scope of Lambda expression is only accessible by the Lambda expression. What is the scope of Lambda expression? So to define that, let's understand with the help of an example. Suppose I defined a class A here, and inside this class, there is public static void main method. Okay, public static void main string args. Now, inside this, I'm making use of Lambda expression. Okay, suppose there is some interface. So I'll take example of the inbuilt interface itself. Okay, so predicate is an inbuilt interface, right? A functional interface in Java. So predicate string type, suppose, and R1 result equals to, and then this is your Lambda expression. So this Lambda expression, suppose, is ending here, and then the main method and the class ends. So here, the scope of Lambda expression is defined such that if the variable is declared inside this class, so int a equals to 4, if I define this over here, and then this int a can be referred inside the Lambda expression, that is over here. If I want to make a is equal to a plus 4, I can do it over here. But make sure, as it is inside static, I have written, so this should be static. But this is what defines the scope of the Lambda expression. That is, if a variable is defined inside the enclosing class of the Lambda expression, then that variable can be accessed by the Lambda expression also. Can be accessed by Lambda expression, meaning inside this curly bracket in the code block of Lambda expression, we can include that. Okay. Second is if the variable is defined inside the Lambda expression code itself. That is, inside this curly brackets, if I would have defined some variable int b equals to 3, suppose, then definitely inside this Lambda expression itself, I can refer b anywhere. So two places, if I define a variable that is inside the enclosing class of a Lambda expression or in the Lambda expression body itself, then those variables will be accessible by the Lambda expression. Okay, just you have to make sure that if you are accessing some variable from a static field, then that should be declared static. But normally this rules applies that the variable declared in scope of Lambda expression should be accessed in Lambda expression only. Okay. First thing was that the return value from Lambda expression has to be stored in a variable of type interface. So you can see here this variable, that is object reference of type predicate. Okay. So these two things are important here to know under Lambda value capture. Now let me talk about method reference in Lambda expression. So method reference meaning how can you refer to any defined method in Java programming from Lambda expressions. Okay, so there are two variations for it. One is static method reference, another is your instance method reference. So first I'll talk about static method reference. Okay, so let's understand this with the help of an example. Suppose inside a class any class, suppose example is the name of the class. Inside this class example, suppose I have a method defined as a static method. Okay, so static void m1. Okay, now this method has certain code here, the implementation code. Now from public static void main method, public static void main string args, I want to make use of the concept of the lambda expression, and I want to call this method m1 inside the lambda expression. Then how can I refer to this static method from lambda expression? So we know that the syntax to be followed is round bracket with parameters, arrow symbol, and curly brackets, and then ending it with semicolon. Right? So here, but we'll use a shortcut method with double colon. So all this will be replaced with just 2 colons. Okay. So how we can do that? So I'm going to use the concept of thread here to call this method. Okay. You can refer it anywhere like that, not necessarily in the thread. So I'm going to create the object of class thread. Okay. And in the constructor for the thread class, I'm going to call this method. Okay. So here to call the static method, and here I'm going to actually write the lambda expression. So normally you would have written round bracket and then this over here. But in place of this, we have a shortcut. Let's understand that shortcut here. So for that, what I'll do is, as it's a static method, to refer the static method, I can just use the class name. Need not have any object or anything. Just directly use the class name, that is your example, 2 colons, okay, and then the name of the method m1. Fine. So this is how we will refer to a static method from the main method, okay, or from the lambda expression. That is, this is the shortcut symbol which can be used. This is equivalent to this part. Okay. Now, how can we refer an instance method? That is, an instance method reference. How can it be done? So for that, I'm going to again have a class. The name of the class, let me have as example itself. And in the class, I'm going to have a method void m1 where I'm not declaring it as static. It will have certain codes inside it. Okay. Now in the public static main method, public static main string args. Now here, if I have to make use of the lambda expression and call this instance method, then how can we do it? Again, I'll use the concept of thread. You can do it in any other way, but the reference mechanism is same. So I'm creating a thread here, new thread, and then here, in place of writing this syntax of lambda expression, I'm going to use double colons. Okay. So here, as it is an instance method, I need an object to call this method. So yeah, I have to create an object of the example class. So I'll create that first here, new example. Okay. And then using this object E and then 2 colons, then the method M1. This is how we will use the lambda expression and call the instance method or refer the instance method M1. Okay, and then you have to definitely write t.start to start the execution of this thread and the method eventually. But this is how we will refer the instance method from the lambda expression code. Okay, you can write in place of this also, which will be perfectly okay. But this shortcut seems easy to understand and even to write. So this is mostly followed. So this is how we will refer the static methods and instance methods from the lambda expression. Definitely here also you should type t.start, then only the thread execution will start. An instance method also you have to do t.start. But important point was here, that is reference or method reference in lambda expressions, both for instance method and for static method. Let us now talk about constructor reference in lambda expression. So how can we refer to a constructor in lambda expression or from lambda expression? So here also, in place of the syntax that was followed for lambda expression, that is round bracket, arrow symbol, and then followed by it will be a curly bracket with semicolon at the end. In place of this, I'm going to use the 2 colons syntax. So let's see the constructor reference, how we can have in Lambda expression. So this is an interface defined here, string message having one abstract method. So it is a functional interface, right? I have written FI for functional interface. So this is the string example class having constructor string example, which takes a single parameter. And here it is just in the constructor, it is appending the string that is passed in this constructor with the already existing string, that is great. Okay, so this is the functionality for this constructor. Now in the class example, in the main method, I'm going to have or refer to this constructor. Okay, a string example constructor. So how it can be done? So with that, you have to define an object reference of string message interface. Okay, this is same string message interface having a object reference equals to. So this is the place where we would write the Lambda expression. So this is the Lambda expression, right? So here, in place of writing that syntax, full syntax, I'm going to use just this. So how can we refer this constructor now? To refer to the constructor, what we have to follow is the name of the class whose constructor has to be referred. Okay, so string example is the class whose constructor is being referred, 2 colons, and then the new operator or new keyword. Okay, so string example, 2 colons, new keyword, semicolon. So this is how we refer to the constructor. And then m1.getString will be called. So getString method will be called of this interface using the object of the interface type, and the string passed is learning platform. So what will happen? This learning platform will be passed to the method getString, right? And as this getString is being referred by this Lambda expression, because it is a functional interface, this Lambda expression is also referring to this constructor which is having already a keyword great. So this text will be passed to this constructor, okay, with the form of string s1. So great plus the string being referred, that is learning platform. So it will be together great learning platform will be the output of this code. Okay, so this is how we refer to the constructor from the Lambda expression. Now let's talk about exception handling in Lambda expression. So why is understanding exception handling in Lambda expression important here? As any other code in Java programming, we can have exception handling. Similarly, for Lambda expressions also, we can have exception handling done. Okay. Similarly, how we do exception handling using try catch block or by using throws keyword, using these constructs of exception handling, programming constructs of exception handling, we can do exception handling in Lambda expressions also. Using the concept of exception handling in Lambda expression loses the authenticity of Lambda expression. What is the meaning of this? So Lambda expression was basically designed with the concept that it will save the coding time, right? And in place of defining a method, we went ahead and worked with Lambda expression so that it will save our coding time, right? And hence eventually improve the performance. But adding exception handling code there will lead to increasing the number of lines of code in Lambda expressions also. So the original intention of having Lambda expression is somewhat seen compromising with the concept of exception handling. So to solve that, what can be done is that a wrapper method can be created that can be used for handling the exception and then pass the Lambda expression as a parameter to the wrapper method. Meaning, we can have a exception handling done with the help of a wrapper method. And this wrapper method will be responsible for handling the exception, and Lambda expression will be created where Lambda expression will be passed as a parameter to this wrapper method. Now you must be thinking that then in that case also for every Lambda expression there should be one wrapper method. Then how is it solving the problem of not increasing number of lines of code? So there we can have a generic wrapper method also, so that the same wrapper method that is responsible for exception handling can be used for many Lambda expressions. Okay. Now let's see with the help of this example how try and catch can be implemented in Lambda expression. So here I'm not using any wrapper method or anything of such sort. I'm simply demonstrating you how in the Lambda expressions itself we can use try and catch. Okay, so here example is of the predicate functional interface. So predicate is a functional interface which has only one test method defined inside it, right? It is inbuilt defined in Java. So I'm making use of it here. So from the main method of a class example. So you can see this is the Lambda expression part from here to here, right? And this Lambda expression, if I want to do exception handling, then I have to include this code inside try and catch block, right? So you can see here, this is the code for the Lambda expressions, which has been included inside try block, and then followed by which there will be a catch block, okay, which will print the information or handle the exception basically. Okay, and then outside this try and catch block and outside the Lambda expression, this method test has been referred or called, which is defined or declared inside the predicate interface. Okay, so you can see here that unnecessarily 1, 2, 3, 4 lines of code is added. So although Lambda expression would have saved some performance or saved some space by writing less lines of code, try and catch block didn't let Lambda expression achieve its benefit. So what can be done in this case? That we don't have to include try and catch again and again. Then in that case, we can have a wrapper method defined. So you can see here in this class, I have defined a wrapper method. Okay, the name I have given of the method is wrapper p itself. The name can be anything, need not be wrapper, but there has to be a method. Okay, so method where it will take the parameter as the Lambda expressions itself. So you can see here, this is the output of the Lambda expression which is being referred by this object P1, right? And output of the Lambda expression is being referred by the object P1, reference P1, which is of type predicate integer, right? So this will be the input to the method, wrapper method. That is, it will be the parameter here. Okay. And the return type will be definitely this itself. Now, inside this, we can write the code whichever we wanted for Lambda expression to have. So we can include the Lambda expressions over here with the try and catch block. Okay, so we can have the catch block also followed by this as this ends here. Okay, so we can have the catch block followed by it, not here. It should have catch block followed by this. Okay, exception E, and then as system.out.println, system.out.println E. Okay, so catch block definitely should be there followed by try, or at least finally block. So here I'm telling about catch block itself. So you can see here inside the wrapper method, now this has been done. From the main method, what is done is that this wrapper method is invoked and the parameter which was passed here, that is p1.test, the method was called using this object p1 dot and the method name, right? So that p1 dot method name and system.out.println will be there, but this will be the Lambda expression now. Okay, the parameter to this method will be a Lambda expression. So you can see parameter, arrow symbol, the body of the Lambda expression. So these two things you have to remember. We can define a wrapper method there. Okay, the input or the parameter to the wrapper method will be of the type interface itself, that is this part. And then while calling the wrapper method, as it is a static method, we don't need any object here, but directly we can call it. And while calling it as a parameter, we have to pass the Lambda expression itself. Okay, so this is how we can have exception handling done in Lambda expression. Now you must be thinking that how is this whole concept of wrapper method reducing the number of lines of code? It is not. If there are multiple Lambda expressions in the code, in the complete program, this will end up adding many new lines of code. So in that case, we can have a generic type wrapper methods, meaning not integer. We can have a generic type wrapper methods, which can be used for various such Lambda expressions. Okay, so this is all about exception handling in Lambda expression. Now let's summarize the complete content. So I have been talking about Lambda expressions in this video, where I discussed about what is Lambda expression, why was the use of Lambda expression there in Java programming as it is a newly added specification in Java, and how to write a Lambda expression also we discussed with the complete syntax of it. And then with the various examples, we tried understanding the different aspects of Lambda expressions, like how can we do method reference, static method reference, how can we do instance method reference, and how can we do constructor reference from Lambda expression. So then we also talked about what is functional interface, because functional interface plays a very important role under Lambda expression. And how can we implement a functional interface using Lambda expression was also discussed. Finally, I talked about the exception handling concept in Lambda expression. That is how, with the help of try-catch block, we were ending up exploiting the authenticity of Lambda expression. But with the help of wrapper method, we somehow tried to manage this compromise of Lambda expressions with exception handling. So I hope you liked all the concepts which I discussed about Lambda expressions in Java. Thank you. If you haven't subscribed to our channel yet, I want to request you to hit the subscribe button and turn on the notifications bell so that you don't miss out any new updates or video releases from Great Learning. If you enjoy this video, show us some love and like this video. As it said, knowledge increases by sharing. So make sure you share this video with your friends and colleagues. Make sure to comment on the video if you have any queries or suggestions, and I will definitely respond to your comments.